Good day everyone, I am Charina P. Rogo, Bachelor of Physical Education, and today I will be discussing the mean from group data in a form of frequency distribution. So if you guys still wondering what is the group mean data, you can easily watch the previous reports of our classmates so that you will be able to gain more understanding about our discussion for today. So mean from group data is a form of frequency distribution is applied when the number of cases, or n, is 30 or more. There are two methods in computing the mean from group data. These are, first, we have the midpoint method. Number two, we have the class deviation method. So frequency distribution is one of the methods on how we present the data. So when we say frequency distribution table, it is a tabular arrangement of the gathered data by categories and by their corresponding frequency and class mark. Okay, let's start here from our first method, which is the mean midpoint method. Is done by getting the product of the midpoint and frequency. So this is the formula where x bar is arithmetic mean and the summation of frequency and midpoint is sum of the product of midpoint times frequency, and n is the number of cases. Okay, we have table 5.1, computation of the arithmetic mean using the midpoint method. So this example is from a reference book and I will be explaining it to you. So we have here the class limits, the frequency, midpoint, and frequency multiplied by midpoint. So as you can observe, our highest interval is 96 to 100 and our lowest interval is 46 to 50. And the smaller number here, this line, is what we call the upper class limit, and the biggest number or the bigger number is what we call the upper class limits. So we have frequency. Actually, this is already discussed in our previous reports, but for you guys to make it more clearer, I will explain it again. So first, we have 3. That means that 3 students got scores between 96 to 100. 5 students got scores between 91 and 95. 4 students got score between 86 and 90, and so on. That's it. Next, we have the midpoint. Okay, we're going to apply the formula 5.3 in this midpoint method. So we have step 1, compute the midpoint of all class limits, which is given the symbol m. So the midpoint is a specific number between the lower and the upper class limits. That means it's the number between 96 and 100. That is 98. And what is the number between 91 and 95? That is 93. 86 and 90, 88, 81 and 85, 83, 76 and 80, 78, 71 and 75, 73, 66, and so on. Okay, we have the step 2, multiply the midpoint by the corresponding frequencies. As you can observe, every midpoint has a corresponding frequency. So you will just have to multiply it. 98 multiplied by 3 equals 294. 93 multiplied by 5 equals 465. 88 multiplied by 4 equals 852. 83 multiplied by 5 equals 415. 78 multiplied by 6 equals 468. 73 multiplied by 9 equals 657. 68 multiplied by 6 equals 408. 63 multiplied by 4 equals 252, and 58 multiplied by 3 equals 174. 53 multiplied by 3 equals 159. 48 multiplied by 2 equals 96. Then we have the step 3, sum the product of midpoint by frequency to get summation of frequency and midpoint. So it means that we have to add this line. So 294 plus 465 plus 352 plus 415 plus 468 plus 657 plus 408 plus 252 plus 174 plus 159 plus 96 equals 3,740. So we have 3,740. And to get the mean, we have to divide this one to the number of cases, which is 50. That is 74.8, which is we're given is the summation of frequency midpoint equals 3,740 over 50. So here's another example. I provided another data using the first method, which is the midpoint method. So again, this is the formula where x bar is equals to arithmetic mean, and the summation of frequency and midpoint is equals to sum of the product of midpoint times frequency, and the n is the number of cases. We have here our class limits. Our highest interval is 100 to 104, while our lowest interval is 50 to 54. And we have the frequency. Frequency is the number of times a data value occurs. So let's say that 3 students got the scores between 100 and 104. 5 students got scores between 95 and 99. 8 students got scores between 90 to 94, and so on. And we're going to add this all to get the number of cases. 358, 3553 plus 356 and 4. That is equals to 50. That is the total number of our cases. So to apply this formula, as I said earlier, we have steps to follow. First step, we have compute the midpoint of all class limits. That means we have to determine the midpoint of each interval. We're going to get the specific point in between this lower and upper class limits. So in between 100 and 104, our midpoint is 102. And between 95 and 99, we have 97. And in 90 to 94, we have 92. And 85 to 89, we have 87. And in between 80 to 84, we have 82. Then in between 75 to 79, we have 77. Then 70 and 74, we have 72. And 65 to 69, we have 67. And 60 to 64, we have 62. And 55 to 59, we have 57. And then last, we have 50 to 54, The midpoint is 52. And after that, let's proceed to the step 2, which is multiply the midpoint by frequency. As you can see, every midpoint has a corresponding frequency. So we're going to multiply the midpoint to its corresponding frequency. So we have 102 multiplied by 3 is equals 306. 97 multiplied by 5, we have 485. And then 92 multiplied by 8, we have 736. 87 multiplied by 3 equals 261. Then 82 multiplied by 5 is equals 410. 77 multiplied by 5, 385. 72 multiplied by 3, 216. 67 multiplied by 3 is equals 201, and 62 multiplied by 5 is equals 310. 57 multiplied by 6 equals 342, and then 52 multiplied by 4 is equals 208. So step 3, we have some. Let's put the formula first before we proceed. Summation of frequency over number of cases. So step 3, we have to sum the product of the midpoint and by frequency. That means you're going to add this all to get the result. 306 plus 485 plus 736 plus 261 plus 410 plus 385 plus 216 plus 201 plus 310 plus 342 plus 208 is equals 3,860. So that means we have 3,860. And the last step is the step 4. Divide the sum by the number of by the number of cases to get the mean, which is 50. You're going to divide this 3,860 over the number of cases, which is 50. That is equals to, that means that our mean is 77.2. So that means our given is summation of frequency midpoint is equals to 3,860 over the number of cases, which is 50. Down to our second method, which is class deviation method. Mean class deviation method. This method gives a shorter way in computing the mean in a form of frequency distribution. The mean value obtained in this method is the same as in table 1. This is commonly used by a classroom teachers in computing the mean, since the shortcut way saves time and effort. This method is known as class division method because it deals with the division of observed values instead of raw scores from arbitrary origin in any of the class limits. The point of origin that is arbitrarily chosen 0. If class limits are arranged from highest to lowest, from highest to lowest, above 0 deviation, above the origin is positive and below is the negative. If class limits are arranged from deviation from lowest to highest, above 0 deviation is negative and below is positive. But since the class limits here is arranged from highest to lowest, that means that the origin are above the 0 deviation is positive and below is negative. So this is our formula and class deviation method, where x bar is equals to arithmetic mean, the midpoint origin, c as class interval. Next we have sum of the frequency times the deviation, and n is the number of cases. So this data from column 1 to 3 is from table 5.1 data. So this column 4 and the 5th, this is what part I'm going to explain. So to apply formula 5.4 of class division method, we have steps to be considered. Step 1, choose any of the temporary arbitrary origin from any of the class limits, either at the bottom, at the center, or at the top. In this case, we choose 71 to 75 as our class limit. Step 2, assign to class limits coded values starting with 0 at the origin, and above 0 deviation is a positive values and below it is negative. That means that in line with our class limit, choosing class limit and deviation is 0, our origin, and above 0 deviation is positive values and below 0 deviation is negative values. Step 3, multiply the deviation by the frequency to get frequency deviation. So we have to multiply our deviation to its corresponding frequency. 5 times 3 equals 15, 4 times 5 equals 20, 3 times 4 equals 12, 2 times 5 equals 10, 5 times 6 equals 6, 0 times 9 equals 0, negative 1 times negative 6 equals negative 6, negative 2 times 4 equals negative 8, negative 3 times 3 equals negative 9, negative 4 times 3 equals negative 12, negative 5 times 2 equals negative 10. Step 4, sum the products of frequency division. So we have to get the summation of the product of frequency and deviation. So we will add them. First thing is we will add this value above 0. 15 plus 20 plus 12 plus 10 plus 6, that is equals 63. And then we will add this value below 0. So that is 45. And we will add them. Then the result is 18. That means that our product of frequency and deviation is 18. So our final step, which is step 5, is compute the mean using formula 5.4 of the class division method. We need to compute the mean using formula, and we will substitute all the given data. So our given data is the midpoint of origin is 73. Our class interval is 5 because it is the number between 71 and 75. And the sum of the frequency times the division is equals to 18, and our number of cases is 50. Okay, so this is our formula. Arithmetic mean is equals to midpoint of origin plus class interval plus the times the product of frequency and division over the number of cases. So our class interval, our midpoint of origin is 73 plus our class interval, which is 5. Next, our product of frequency and division is 18 over the number of cases, which is 50. And then copy the midpoint of origin, plus we have to multiply this 5 multiplied by 18 is equals 90 over the number of cases, and then copy the midpoint of origin, plus we're going to divide these two values. 90 divided by 50 is equals to 1.8, and then we're going to add this two values. 73 plus 1.8 is equals to 74.8, and this is our mean. As you can observe, the mean value obtained using the class division method is the same with mean using midpoint method, which is 74.8. So I provided another data to make it more clearer, and this data is same data I illustrated in my example in table 1. So computation of the mean using the class division method. So we have class limit, midpoint, frequency, division, and the frequency and division. So in applying 5.4 formula of division method, we have steps to be considered, to be followed. First is choose any of the temporary arbitrary origin from any of the class limits, either at the bottom, at the center, or at the top. So in this case, I choose the center, 75, 79 as class limit. Step 2, assign to class limits coded values starting with 0 at the origin. So 75 to 79 is our origin. This means that this is equal to 0. So anything above 0 is positive. Let's start from 1, 2, 3, 4, 5. And any number below 0 is negative. So negative 1, negative 2, negative 3, negative 4, and negative 5. Step 3, we need to multiply the division by the frequency to get the frequency division. So in order to get the frequency division, we need to multiply our deviation to the corresponding frequency. So that means 5 times 3 multiplied by 3 is equals 15. 4 multiplied by 5 equals 20. 3 multiplied by 8 is equals 24. multiplied by 3 is equals 6. 5 multiplied by 1 is equals 5. 5 multiplied by 0 is 0. 3 multiplied by negative 1 is equals negative 3. 3 multiplied by negative 2 equals negative 6. 5 multiplied by negative 3 equals negative 15. 6 multiplied by negative 4 is equals negative 24. And 4 multiplied by negative 5 is equals negative 20. So, step 4, sum the product of frequency and deviation. So, we have to get the summation of the product of frequency and division. So, we will add them. First thing is we will add these values above 0. 15 plus 20 plus 24 plus 6 plus 5 is equals to 70. And then we will add this value below 0. Negative 3 plus negative 6 plus negative 15 plus negative 24 plus negative 20 is equals to negative 68. And we're going to add this two values. 70 plus negative 68 is equals to 2. That means that our product of frequency and deviation is 2. So this is our given. Midpoint of origin is equals to 77. And our class interval is 75, 76, 77, 78, 79, so 5. And then our summation of frequency and deviation is equals 2. And the number of cases is 50. So the last step, which is step 5, compute the mean using formula 5.4 of the class deviation method. That means we need to complete the mean using the formula, and we will substitute all the given data. Let's put the formula first. So arithmetic mean is equals to midpoint of origin plus class interval summation of frequency and division over the number of cases, and then our midpoint of origin is 77 plus the class interval 5 times the product of our frequency and division, which is 2 over the number of cases 50, and then equals to 77 plus 5 multiplied by 2 is 10 over the number of cases. Then copy 77 plus 10 divided by the number of cases 50 is equals 0.2. 77 plus 0.2 is equals to 77.2. And this is our mean. This is the mean using the midpoint method, and this is the mean using the class division method. As you can observe, the mean value obtained using the class division method is the same with mean using midpoint method, which is 77.2. So it's the same. They are both a method that teachers use to get the mean. And that's it. That's the end of my discussion. Thank you.